be good.
Okay, hello everyone. We have been assigned the topic of ice sheets in Greenland that are melting with potential effects on the sea level. So we're going to talk to you a little bit about that today and about how remote sensing applications could potentially address this problem. So ice sheets and glaciers are hydrological resources that play an important role in global climate change. Outside Antarctica, Greenland is home to the only permanent ice sheet. The ice sheet stores 9% of the Earth's fresh water supplies, which is the equivalent of a 7.6 meter rise in global sea levels if this ice sheet were to completely melt. So the Greenland ice sheets have been melting rapidly as a result of global warming. This has accelerated Greenland's ice mass loss from 25 billion tons in the 1990s to a current average of 243 billion tons per year. The constant temperature of glacial ice provides an ideal environment for the preservation of genetic material, in addition to a record of the evolution of ancient biodiversity. So glacial ecosystems have been found to contain active microbial communities and diverse pathogens with unusual genetics, novel life strategies, and the abilities to maintain long-term relationships with hosts. So changing temperatures destroy protective glacial environments, the stable environments that these ancient microbial communities have depended on for survival. So the melting ice will release viable organisms into our ecosystems, causing unknown effects on current species, in addition to losing the evidence of ancient microbial communities that we currently have access to with these ice sheets intact. So we will lose any evidence about the ancient microbial communities and their transportation, deposition, or abilities to preserve themselves.
So as a result of all these problems, there is therefore the need to measure and diagnose changes in the ice sheet's mass balance to help monitor the entire Greenland ice sheets. And the satellite remote sensing have shown promising signs to be a powerful tool for these purposes. Currently, scientists have combined 26 independent satellite datasets in an attempt to track the global warming effect on Greenland and the impact of the ice sheet melt on rising sea levels. So currently the Greenland ice sheet database, GIS database system was designed, and this was designed to help analyze, merge and compare data sheets on different spatial scales and compare with geo-referenced satellite images or area photographs of the ice sheets to help provide insight into the various processes that is acting on the ice sheets. So this multifaceted approach involves the remote sensing, as well as field-based observations is reported to be the only feasible options to monitor the entire Greenland ice sheets. And the retrieval of the albedo satellites have also provided an important marker of changing ice surface. This has been used to show the variability of the spatial and temporal albedo in the ablation zones. And this is driven by the seasonal snow line position, as you can see on the slides, and its control on the bare ice exposure. So the thick black snow line, as we see on the map here, gives a clear extension of the bare ice exposure and the snow melt. So moving on to the next slide, another method that is known as the terra surface reflection have also been used to quantify the regional distribution of the bare ice and the dark ice extent. And the variability of the spatial extent of the bare ice and albedo controls the ice sheet's albedo and the surface met's water production in the ablation zone. Data that has been obtained from this method suggests that the bare ice weathering by solar radiation may reduce the dark ice extent and increase the surface albedo in the Greenland ice sheets ablation zones. So on the next slide, the use of a space-borne passive microwave radiometers provide insight into the climatic drivers of the ice sheet surface mass balance processes, which includes changes in the location and the extent of surface melting. And as you can see on the graph, where we have the white color in the blue color shows where it has not been melted so far. So you could see that there were completely melt in July, and there was a few melting in a few surfaces, but that was not melted in June. And in August of 1972 to 2012, there were also some few portions of the ice sheet that has not been melted. So data that has been obtained from, now go to the previous slide. So data that has been obtained from the use of these methods also suggests that the area of the active surface melt over the Greenland ice sheets has approximately doubled since the early 1990s, with a trend of 40,000 kilometers per square every year. So in summary, what we are saying is that the Earth observing satellite that is sensitive to visible infrared and microwave electromagnetic radiations have documented the patterns of change of the Greenland ice sheets melting. So in future progress in the remote sensing of this ice sheet melting will benefit from methods that directly addresses the complexity of this problem. Thank you. So these are some sources that we used for our presentation. That is it. Thank you.
Thanks.